Question 2 was on the inventory management, which is purchasing module. It was on module 1. Okay. So, for purchasing module, we have the following formulas. So the first one is, okay, so first one is economic order quantity, which has to do with 2ds over C. Okay, so 2ds over C is square root. So meaning that our G is annual demand. So D is annual demand, and S is ordering cost per order. Ordering cost per order, and C is carrying cost per unit per year. Okay, so carrying cost per unit per year, or holding cost. Then number of orders in a year to meet annual demand. Okay, so orders in a year to meet annual demand. So this is N is equal to D over Q. Okay. Then number 3, we have cycle time between orders. Okay. So the time between orders for CT is equal to Q over D multiplied by weeks or days of the year. Then we have reorder point is actually equal to expected demand during lead time plus what? Safety stock. So expected demand during lead time is actually equal to daily demand multiplied by lead time. Okay. Then our safety stock is equal to Z value multiplied by standard deviation of demand multiplied by the square root of lead time. Okay, so the square root of what? Lead time. So these are the formulas to use as we are looking at calculating the safety stock. Okay. I'm sure we are together. All right, so let's move on. We can now look at the aspects where we look at the total stocking cost is Q over 2 by C in plus D over Q by S. Okay, so this is the annual holding cost. So this is holding cost This is the ordering cost. So this is what goes on here. All right, so, okay, so these are the formulas to do with the inventory management model one. Okay, so for the sake of those who have just joined in, you can capture the formulas. So this is how many units that the firm should order at a time. Okay, so EOQ means the economic order quantity. So economic order quantity. So how many units of commodities the firm should order at a time is the EOQ. Number of orders in a year to meet annual demand. So annual demand then over the EOQ. The cycle time between orders is Q over T multiplied by days or weeks of the year. Reorder point is equal to expected demand during this time plus safety stock. So safety stock in this case, when there's no probability of stock out, when no stock out, we have Z value multiplied by standard deviation of demand multiplied by the square root of lead time. Okay, so this is how you calculate there, how you calculate the safety stock. In total stocking cost, I is talking about ordering cost and ordering cost. So quickly, you can go to the quiz. So in this quiz here, it says the Rungush operates 52 weeks a year. Okay, so as we look at that one, for question 2, okay, so we have our weekly demand is 132. So our weekly demand is 132, 52 weeks. Then order cost is $74. Holding cost, holding cost is 24% of cost. 24% of cost. Service level, 95%. Lead time is 3. Standard deviation of demand is 25. So as we do a summary on this end, okay, we are simply saying that for this question 2, the weekly demand is 132 per week. Then we have 52 weeks. So we can find our annual demand, which is 132 multiplied by 52. Our demand gives us what? Okay, 132 multiplied by 52. Okay, so what are we getting as a value there? So 132 by 52, we are getting 864. This is annual demand. Okay, so meaning that our holding cost 24% of cost, our cost there. Okay, of course, the information that we have lead time of 3 weeks, standard deviation of demand of 25. Okay, 25. All right, so and then the other information that we have here is unit cost is okay, the unit cost is 5.65. That's what we have as a unit cost. So 5.65 is the unit cost. All right. So 5.65 meaning that 0.24 times 5.65, we are getting what? We are getting 1.356. 1.356. So 1.356. Then order cost is 74. All right. Then our service level is actually 95%. So you can find our economic order quantity 2DS over C. All right, so 2DS over C, that's our economic order quantity. Economic order quantity 2 multiplied by our annual demand. Okay, so from here, our annual demand is, okay, 6864. So 6864 times 74. 74 is the order cost over carrying cost 1.356. 1.356. So our economic order quantity will give us what? 2 times 864 times 74 divided by 1.356. Then the square root. So it's giving us 865.5. So as we round off here, to give us 866. So 866 is our what? Economic order quantity. So once you get that one right, other things are straightforward. So 866 is this one here. Okay, time between orders is cycle time, 2 decimal places. So you just start inserting in. Okay, so for part, this is part 1, part A in short, and part B is equal to cycle time is equal to Q over T multiplied by weeks of the year. So cycle time is equal to 866 over demand is what? 864. 864 multiplied by 52 weeks. So our cycle time will give us what? 866 divided by 6864 times 52 is the 6.56 weeks. So this answers the second part of the question. Okay. And what is the order point? The whole number, no commas. The order point is a point at which we can order units of a commodity again. So the order point, I gave the formula, is equal to expected demand during lead time plus the safety stock. All right, so that's number C. Okay, you're behind, let me know. Okay, the order point, expected demand during lead time plus the safety stock. Okay, so our order point, now the aspect of getting the expected demand during lead time. So where expected demand during lead time is equal to weekly demand times lead time. Our weekly demand, you come here, demand per week was how much? 132 per week. That was our weekly demand. Okay. This one is 132 per week. And the lead time is 3. So we multiply those ones to get expected demand during the time. So it's giving us 132 by 3. Okay. So 132 by 3 is giving us 396. Okay. And let's find the safety stock. Safety stock is equal to Z value multiplied by standard deviation of demand. Lead time. Are we together?
Give me the paper. I think it's on my bed.
All right, so this is what is happening. So
Okay, wait, I think I have it.
meaning our Z value, get the Z value, use the service level of 95%, then Z is equal to, we check for 95% from the table. All
What
right,
time I studying?
okay.
For more? So you're
Pardon?
playing first before you go and read. Have you touched your books today? Before you go anywhere, touch your books.
So this
Me, you
is
see
what's
me here. I'm
happening.
always on my books.
So this is it, what is going on. Okay, so if you can see here, the service level of 95%, the same as 0.95. Okay, so 0.95. So check for 0.95 inside the table. Inside table. So what is 0.95 inside the table? The closest. So you go to the table and get a 0.95. Okay, 0.95 is actually here. So it's 1.65. So Z is equal to 1.65. All right, so after you get the 1.65, we can come and find the self to stock 1.65 multiplied by the standard deviation of demand. In this case, here, standard deviation of demand was 25. Standard deviation of demand was 25. Okay, so 25 is standard deviation of demand from here, 5 boxes. So you put in 5 boxes there, all right? So this is it, what goes on. Okay, so you put the 25 boxes multiplied by the square root of lead time is 3. Okay, our lead time from the question is 3 weeks. So meaning we can get 1.65 times 25 times the square root of 3, 71.447. So meaning, therefore, our order point is equal to expected demand during lead time plus the safety stock. Okay, so it is 396. Okay, then plus 21.447. Okay, so 467. So 467 is a order point. Order point. All right. I'm sure we are together so far. Okay, you're following? Then that's our order point. 467. Then Mlungoshi Village uses lot of 600 boxes. What is the annual total stocking cost? 2 decimal points. We are using Q in this case as 600 boxes. Okay, so meaning our total stocking cost. Okay, so total stocking cost to be equal to, you get this formula here. Okay, so total stocking cost, our total stocking cost will be equal to Q over 2 by C plus D over Q on S. So total stocking cost, we're using 600 over 2, 1.356 plus annual demand is 68.64 over 600 by 74. So our C is actually 1.356. Then of course, we have our S is 24, annual demand is 68, 64. All right, so 52 weeks of the year, So I'm sure people are with me so far. So our total stocking cost will be equal to 600 divided by 2 by 1.356, 406.8 plus 34 divided by 600 times 74 is 846.56. So our total stocking cost in this case will be, okay, giving us 1253.36 dollars. 1253.36, as we can confirm here. Okay, 1253 point what? To this one here, 1253.36. What would be annual total stocking cost if they move from 600 to the economic order quantity? The economic order quantity was 866. So to find the total stocking cost at EOQ. Okay, so first T, find TSC at EOQ of 866. So total stocking cost Q over 2 by C plus D over Q on S. So our total stocking cost is equal to 866 over 2 on 1.356 plus the demand is the 864 over 866 by 4. So our total stocking cost will give us what? 866 divided by 2 by 1.356 is equal to 587.148 then plus 8 to 4 divided by 866 times 74. 586.531. Our total stocking cost to give us 587.148 plus 586.531. 1173.679. So let's find the savings. Our savings will give us what? 1253.36. 1253.36 minus 1173.679. Okay, 1253.36 minus that, to giving us 79.68. 79 point what? 68. So we have 79.68, which is this one. All right, suppose that the weekly demand is, instead of 134, it was supposed to be 83. How much higher will be the cost owing to the distorted EOQ? So let us find the new EOQ at weekly demand of who? Of what? 83. So new EOQ. Okay. Weekly demand of 83 per week, meaning that our annual demand will be 83 by 52. So this one will give us 83 by 52, 4316. Okay, our EOQ will be equal to 2GS over C. So our EOQ equal to 2 multiplied by 43, 16 by 74. Okay. By what? By 74 over 1.356. Our EOQ will give us what? 6 by 74 divided by 1.356. So 686.3. Okay, 686.3. Okay, so total stocking cost will be Q over 2 by C plus D over Q on S. So total stocking cost in this case would be 686.3 over 2 by 1.356 plus 4316 over 686.3. Then by what? By 74. So our total stocking cost equal to 686.3 divided by 2 by 1.356. 465.31 plus the other one, 4316, 68, okay, 686.3 by 74. Okay, so 465.37. So our total stocking cost in this case would be 465.31 plus 465.37, 930.68. So our savings, new savings will be equal to, okay, using the, so this one we have 1173.678, 1173.678. So we have 1173.679 minus 930.68. So it's giving us approximately 243, round of the whole number. It's approximately 240, 243. So let's say 243 we found here. So suppose that the actual demand is 83, ordering cost was the 25. We're using the internet to place an order. However, the purchasing does not tell anyone, and EOP is not adjusted. Okay, effect this reduction. How much higher will the total stocking cost be? So we are going to find a new EOQ. Okay, we're going to find new EOQ at demand per week is 83 times this is per week. Okay, 83 per week. And then ordering cost becomes $25. Okay, so this one becomes $25. So meaning that our annual demand is actually going to be 83 by 52. So 83 by 52 is 4316. Or EOQ will actually be 2DS over C. Okay, so for EOQ will actually be 2 times 4316 by 25 over 1.356. So this one will give us now, okay, so 2 times 4316 times 25 divided by 1.356 square root as 398.92. Okay, so 398.52 2, okay, or just 399 as EOQ. So 399 for EOQ equals 399. Total stocking cost Q over 2 by C plus D over Q on S. So our total stocking cost will be equal to 43.16 over 2 by 1.356 plus 4316 over, okay? So, okay, so we're getting down to EOQ is 399 over 2, 399 as the quantity and 25 on this end. So our total stocking cost to give us 399 divided by 2 by 1.356, 270.522 plus 4316 divided by 399, 25, 270.426. So total stocking cost will give us 270.522 plus 270.426, 540.948. So our savings now, new savings will be equal to, okay, our new savings will be equal to 30.68. So 930.68 minus 540.948. So 930.68 minus that 389.7. So this is our new savings. All right. So this new savings is 3 here to 2 decimal places, 389.73. That is the correct one. So $389.73. So this is where this question comes to an end. So this is where we have looked at the model 1, which is the purchasing model. So these questions, we are on 2 models altogether. Okay, so the first question was on model 2, which was on production, which we have covered. And this question is on the inventory management model 1. Okay, so this is where we end our class. Unless there are questions. Are there questions so far? Have you followed? Excuse me, have you followed?